Alright guys, today we're going to look at lesson 3, which is calculating atoms. So we're going to use what we've called Avogadros number. Avogadros number is the number of atoms in 12.01 grams of carbon. Its numeric value is 6.02 times 10 to the 23rd. And so that means that in a 12.01 gram sample of carbon, that contains 6.02 times 10 to the 23rd carbon atoms. So how to convert from moles to atoms. First, we're going to write down the unit that we asked for. This is kind of like going to be our stepwise procedure on how to do this. Then we're going to write down what value is given. Then we're going to apply a unit factor to convert the given units to the desired units. So we're going to go back to the way that we did it at the beginning of the year where we used dimensional analysis. So let's look at a couple example problems. And we will go through this step by step and we'll go slow. Make sure you make a lot of notes and make sure if you have any questions you write them down in your notes so you can ask me tomorrow in class. So example 1, how many sodium atoms are in 0.12 moles of sodium? So first, step 1, what do we want? Read the question and what do you want to find out? We want to find the number of atoms of sodium. What were we given? We were given that we started off with 1.120 moles of sodium, and then we're going to use a conversion factor. We know that 1 mole of sodium is equal to 6.02 times 10 to the 23rd atoms of sodium. So we're going to set it up in a dimensional analysis way. So we're going to start off with what you were given, 0.12 moles of sodium. Then you're going to multiply by the conversion factor. So 6.02 times 10 to the 23rd atom goes on top, 1 mole's on the bottom. Now we want to set it up this way because we want moles to cancel. Since we have moles on the top here and moles in the bottom here, they do cancel. Then you're going to take out your calculator and you're going to plug in 0.120 times 6.02. Remember, we're going to have to use that second EE button. So that EE to the 23rd, and we are going to get 7.22 times 10 to the 22nd atoms of sodium. So that's the first problem. And since we have 3 significant figures here, our answer has 3 significant figures, we're good to go. Let's look at example problem 2. How many zinc atoms are in 4.25 moles of zinc? Let's do our steps again. First, what do we want? We want atoms of zinc. What were we given? We were given that we were starting off with 4.25 moles of zinc. And what's our conversion factor? Our conversion factor is that we have 1 mole of zinc, which is going to be equal to 6.02 times 10 to the 23rd atoms of zinc. So we're going to set it up just like we did last time. 4.25 moles of zinc is going to go first. Then we're going to put 6.02 times 10 to the 23rd atoms of zinc over 1 mole. Moles are going to cancel. That's what we want. Remember, we're looking for atoms. And then we're going to plug that into our calculator. We're going to do 4.25 times 6.02 times 10 to the 23rd. Remember, again, we are going to type in 6.02 second EE or EE to the 23rd, and that we will end up with 2.56 times 10 to the 24th atoms. Again, we have 3 sig figs in the number we started off with. We have 3 sig figs in the number we're ending up with. So we're good. Now let's try a practice. Try this in your notes. It's going to be set up the exact same way as example 1 and example 2 are. So I want you to try this. So pause the video, and when you're done, try it. Unpause it. All right, welcome back. So what did you do? Step 1, what do we want? We want atoms of titanium. We're given moles of titanium, and we know that 1 mole of titanium has 6.02 times 10 to the 23rd atoms of titanium. So we're going to start off with our 11.5 moles of titanium. 6.02 times 10 to the 23rd atoms of titanium is going to go on the top. And then our moles cancel, so we know we have it set up right. And then we're going to do 11.5 times 6.02 times 10 to the 23rd. And that's going to equal 6.92 times 10 to the 24th atoms of titanium. Let's try another practice. How many carbon atoms are in 0.23 moles of carbon? Pause the video and unpause it when you are finished. Great, well, welcome back. So now let's try this. We want atoms of carbon. We're given 0.23 moles of carbon. So we know that 1 mole of carbon has 6.02 times 10 to the 23rd atoms of carbon. So we're going to set it up like so. Moles are going to cancel, and we're going to be left with 1.34 times 10 to the 23rd atoms of carbon. So all of these examples have been going from atoms, or from moles, excuse me, to atoms. So that's what your understanding is. So I want to know how many atoms are 3.33 moles of helium. So what I want you to do is I want you to try this, and we're going to talk about this in class tomorrow. Now let's look at another way. You can go from atoms to moles. So this is the opposite. We're going to follow the same three steps, and we're going to set it up just like we did with our first problems. So let's look at an example. So how many moles of potassium are in 1.25 times 10 to the 21st atoms of potassium? So we want moles of potassium. We're given atoms, and we know that 1 mole has 6.02 times 10 to the 23rd atoms. So we're going to start off with what we're given. Now, instead of atoms, 6.02 times 10 to the 23rd atoms are going to go in the top, it's going to go in the bottom. And remember, when something goes in the bottom, that means we divide by that. So when you type this into your calculator, you're going to take 1.25 times 10 to the 21st divided by 6.02 times 10 to the 23rd. And when you do that, you're going to get 2.08 times 10 to the minus third moles of potassium. You have 3 sig figs here. Started off with 3 sig figs, so you're good. Let's look at example 2. Same thing. How many moles of aluminum are in 5.75 times 10 to the 24th atoms of aluminum? We want moles of aluminum. We started with atoms. We know that 1 mole has 6.02 times 10 to the 23rd atoms of aluminum. So we're going to set it up. We're going to put atoms on the bottom. So 5.75 times 10 to the 21st, 10 to the 24th. We're going to cross off our atoms, and that's going to be divided by 6.02 times 10 to the 23rd. We're going to equal with 9.55 moles of aluminum. 3 sig figs here, 3 sig figs to start off with, so we're good. Now try your practice on your own, and unpause the video when you're done. How many moles are in 3.96 times 10 to the 24th atoms of barium? So we want moles of barium. We started off with atoms of barium. We know that 1 mole of barium has 6.02 times 10 to the 23rd atoms. So we're going to set it up like we've had, just like we did with our examples. And you should end up with 6.58 moles of barium. 3 sig figs to start off with, and the number I gave you. 3 sig figs to end up with, so you're good. Look at another practice. Try this on your own, and unpause when you're finished. Great, well, welcome back. So, how many moles of xenon are in 1.08 times 10 to the 25th atoms of xenon? We want moles of xenon. We're given atoms. We know that 1 mole of xenon has 6.02 times 10 to the 23rd atoms in it. So, we're starting off with atoms. Atoms need to go in the bottom so that we can cancel. We're going to divide 1.08 times 10 to the 25th divided by 6.02 times 10 to the 23rd. And we're going to end up with 18.0. 3 sig figs here, 3 sig figs here, so we're good. Here's your check your understanding. Again, try this at home, and then we're going to talk about this first thing in class tomorrow.